In an earlier video, we've looked at this linear function. Where C represents the production cost and X represents the number of anvils that we are manufacturing at Acme Manufacturing. Well, when you make a product, you intend to sell the product, don't you? And you intend to make money as you sell that product. That gives rise to another function that we can work with. Let's suppose we sell our anvils at a price of $85 a piece. That would enable us to write this new function, which we could represent with the letter R for revenue. This is our cost function. This is now our revenue function. We get in revenue $85 for every anvil. So the X here also represents number of anvils. Here, we're making those anvils, and then we're going to turn around and sell them at $85 a piece, and that produces this revenue function for us. Well, one of the important concepts when you are in a situation like this, where you are making a product, selling the product, is the concept of break even. How many, in this instance, anvils do we have to make so that the revenue will cover the cost? So what value of X do we have to have so that 85X is the same as 35X plus 2,500? We want that revenue to equal the cost for some specific value of X. In fact, that's the question. And this point at which the revenue covers the cost is called the break-even point. So the question is, how many anvils, what value of X, because remember that's what X represents, the number of anvils, what value of X, how many anvils do we have to make and sell so that the revenue covers the cost? And that's actually a relatively easy quantity to find. Revenue is 85 times the number of anvils we're going to sell. Cost is 35 times the number of anvils we make plus $2,500 more. So there is some value of X where 85 times X equals 35 times X plus 2,500. That's my break-even point. That's how many anvils I have to make to break even. And any anvils that I make over that are going to start to produce profit for me. Well, look what we've produced. This is a nice linear equation in one variable, isn't it? Can't we simply subtract 35X from both sides? Which gives us the equation 50X equals 2,500. So when I divide both sides by 50, I get X equals 50. And that tells us that we need to make and sell daily, because these were daily functions. We need to make and sell 50 anvils a day in order to break even. That's a very important value to know if you are in, as we have here, a manufacturing setting. How many of your product do you need to make and sell in order to have your revenue cover your cost, in order to break even? So we can perform this kind of break-even analysis. We take our cost function and revenue functions, set them equal to each other, solve for X. That tells us how many of that particular item we have to make and sell in order to break even.